Graphing the secant and cosecant parent, something very easy to do. To help us with these, we're going to graph the reciprocal. Now there's some notes down here to help you follow along, and we'll kind of mention those as we go through these. So we're going to graph the secant function first, very easy to do. Just remember that the secant is really the reciprocal of our cosine. It's 1 over the cosine function. So if you know that, it's actually pretty easy to do. So what I'm going to do is I'm going to make another little table here for my cosine of theta. And the cosine of 0, everybody remember, should is 1. And if you flip it, it's 1 over 1, so it's just still 1. The problem occurs when we get to pi over 2. It becomes 0. Well, if I do this, I'm going to get 1 over 0, which is a d and e. So we get a does not exist here, undefined. We actually get asymptotes. At pi, cosine of pi is -1, so that gives me -1. 3 pi over 2 is 0, so it gives me another undefined. And at 2 pi, we're back to 1, so my value is 1 again. So when I'm graphing this, something very easy to do, keep in mind, if you can graph the cosine function, you can graph the secant curve, because that's what we're going to do. We're going to graph our cosine curve instead. So the cosine curve, remember, starts off at 1, and we're going to graph it. I'll graph it in red here, because we'll see in a second why. Cosine every pi over 3, every pi over 2, we get a little tick mark right there, pi over, so there's my pi over 2, 1, 2, 3. There's pi, 1, 2, 3. There's 3 pi over 2. Going backwards, 1, 2, 3, 1, 2, 3. Negative pi, 1, 2, 3, negative 3 pi over 2. And when I graph my cosine curve, we should remember what it looks like. Remember, it looks like the world, whoops, go down one more, the world famous Warnow function, and somehow I messed up. There we go. It should look like that. Now I'm going to draw it dashed. And the reason I want to draw it dashed is because I'm not really graphing the cosine curve. Remember, I'm really graphing my secant curve. But here's how I do this. Remember, everywhere cosine was 0, it was undefined. Well, that means there's an asymptote. So here's an asymptote, and I draw it in. Here's an asymptote. Everywhere it crosses the x-axis, we get an asymptote. Here's an asymptote. And here's an asymptote. Now my rule, very simple. Here's what it says. So we found the functions where the function equals 0. These are your asymptotes, or where the function is undefined. Locate the maximum and minimums. Very easy to do. So here's a maximum. And I draw my secant function. Now the secant function follows the asymptote. So it's going to go up here. And if it's a minimum, both sides go down. A maximum, both sides go up. Both sides go down. And up. Now there's one more. It actually does continue over here, but since we can't see it, we don't have to worry about graphing that part. So there's, in blue, is my secant curve. Secant of theta in blue. Now a lot of times what you can be asked though is find the asymptotes. So once you graph it, it's actually pretty easy to do. It's going to be at the pi over 2's, every pi over 2. So I start with x equals pi over 2, plus or minus, to get all of them now, we're going to take a look here. Well, my next asymptote is pi units over. So plus or minus pi, and we say k to keep it in general to get every single one of them. And there's our secant curve with its asymptotes. To get the cosecant curve, same thing, except for cosecant is 1 over the sine of theta. So I make my sine curve, my sine chart, sine of theta. Sine of 0, we should remember 0. So there's my undefined. So sine has my asymptotes at zeros and pi's. 1, 1, 0 at pi, so that makes it another asymptote. -1 at 3 pi over 2, which makes it just -1 here, 0 back here, so there's my asymptote. So again, graphing it, remember I'm going to graph the cosecant, but what I'm going to really graph is my sine graph. Okay, so my sine curve, remember, starts at the origin. And we go pi over 2's just to get our point. 1, 2, 3, 1, 2, 3, there's negative pi, 1, 2, 3. And now when I graph my sine graph, remember, just to get my graph, we notice I'm scaling by ones here, just so we can see it. If you don't do that, that's okay. Don't worry about it. I just want to make mine so we can see it. And I'm going to graph it in red and sketch it. Remember, I'm only going to do a dotted graph here because I'm not graphing sine. I'm going to use a dashed line because I'm not graphing sine, but I use it to get my cosecant graph. And this time, everywhere we cross the axis, there's my asymptote, negative 2 pi. There's negative pi. There's 0. Here's pi. And there's 2 pi. Same thing before. I'm looking for the peaks and valleys. I'm looking at all the max and min. So here's a maximum. So what does it mean? Cosecant goes up here. Cosecant goes down here. Cosecant goes up here. Cosecant goes down between pi and 2 pi. Cosecant is negative. We can kind of say it like that. It's kind of cool to say. And there's our graph. In blue is our cosecant. Is in blue. And again, let's talk about the asymptotes. To get the asymptotes, remember, we started off at 0 with my first one, and you can really start anywhere you want to, but we're going to start at 0. You could start at pi. Heck, if you want to be crazy, start at negative pi. It's all the same way. So my first one's at 0. I'm going to use plus or minus, because it goes forward and backwards. Every pi units is an asymptote. So every 0 plus or minus pi k. And there is our cosecant curve. So we're going to take a look at graphing a few of these together. Okay, so let's take a look at a couple to graph together. The first we're going to take a look at, here it is, number 1. 2 cosecant theta minus 1. Now pretty much everything is done the same. So to graph these, very simple to do. We're going to get our period. It doesn't change. It's a sine. This is a sine curve. So our period doesn't change. It's still 2 pi. Whoops, that's a weird looking pi. 2 pi over b, which is b is just 1 again, so it's still 2 pi. So it's still going to repeat the same. Again, we don't really worry about the steps. That's for another class. There is no phase shift. We'll get the asymptotes later. I like to get my asymptotes in the graph. There is a vertical shift, negative 1, so we're going to go down, of course, just like a disco clown. And we do have an amplitude, so I probably should mention that, right? That will affect our graph, of course. Amplitude, not food. I'm hungry. We get A is 2. That's going to multiply our y values by 2. So again, remember, I'm not going to graph cosecant. I'm going to graph sine. So I'm going to graph my sine of theta. And from here, I'm going to graph my transformation. So step 1, graph your sine. Step 2, graph your transformations. Okay? Now, the vertical shift will come and play for us again. Remember, this is called our midline. That's going to help us to also graph this. So when I graph it, I'm going to graph sine. Remember, we know what sine looks like. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. There's pi. There's negative pi. So I dot my sine. Do-do, 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 do-do. And then I do my transformations. Y times 2, that's easy, down 1. Y times 2 puts me up to 2. Remember, there's my 2. Down 1, right back where I started. Down 1. Times 2, down 1. Down 1. Times 2, down 1, right where I started. Times 2, down 1. Times 2. Remember, there's negative 2. Down 1, and then just down 1. So we have our graph. Now again, what I'm going to graph is I'm going to dot, make a dash line for my sine curve. This is what my sine function would look like. And we're all really good at that. Now, to get the asymptotes, it's not where it crosses 0 really, it's my midline. So I'm looking for my midline here. So if I graph my midline, okay, there's my midline. So the third step I'm going to do is I'm going to find the midline. Okay? These are where your asymptotes will be located. These will be where your asymptotes are located. Everywhere it crosses the midline is an asymptote. So I draw my asymptotes here, 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 and here. And next, what I'm going to do is I am going to find my peaks. There it goes up towards the asymptote. Now it kind of looks weird. We got to kind of graph this. Goes down, doesn't have to be perfect. Goes up and goes down. And there's our graph. Of course, let's get our asymptotes. Remember, it's sine, so it's, oh look, there's an asymptote. Is at 0. So I'll go x equals, don't forget your x, 0 plus or minus pi k. And that gives us every single one of them. Okay? Very good. Now, we also were asked to find the domain and range down here. So let's take a look here. The domain, be careful, is just very simple. It's all real. And we would say this. We're going to actually not even going to use our interval notation. We're going to use a set builder, all x such that x cannot equal 0 plus or minus pi k. We're saying it could be any x but the asymptotes. To get the range, very simple. Just like here, I'm going to use my set builder, my interval. It's from negative infinity to negative 3. It can include negative 3, or starts up here at 1 and goes up to infinity. And there's our domain and range. All right. In part 2, we're going to graph a couple more of these, so please stay tuned. Make sure you check those out. If you need to, go back and look this one over. Thank you.